So I'm sure you all just finished acing your first unit test in here, and so we're ready to go ahead and get started on Unit 2. Our first section is on functions and slopes, and so that should be something that you are familiar with, both of those words. Might need a little bit of a refresher though. A function. By definition, a function is a relation with exactly one output for each input. That's a math book definition. Oftentimes math book definitions are not easy to follow. What we're really saying here is if you plug x into an equation, you should only get one y value out. If that is the case, then we're talking about a function. If you get multiple y values out based on your x value or your input, then we're talking about a non-function. So a simple example would be an equation like y equals 2x minus 7. That is a function because if we plug 3 in for x, we get 6 minus 7, which is negative 1. It can only be negative 1 for y when x is 3. That makes it a function because it has a distinct output value. An example of a non-function would be an equation like 3 equals x plus y squared, where if you would plug negative 6 in for x, add it to the other side, we get y squared equals 9. If you take the square root, you get 3 or negative 3 as your solutions. So by plugging negative 6 in for x, we get two y values that are different for outputs. That would be an example of a non-function. Now we need to also consider that functions can be represented visually as a graph, and so the checking for a function on a graph is much easier than checking for a function in an equation. You don't have to plug anything in, you don't have to do any work. All you have to be able to do is draw a vertical line. So the vertical line test says if you can draw a vertical line through the graph, it will intersect the graph at only one point. That is how you decide if it's a function. And if we look at our examples here, our first one, even though that graph in red is a wavy line, it is still a function, because if I draw a vertical line at any point, it will only intersect the graph at one point. And so you see I've drawn two separate vertical lines and circled the intersection point with the graph, and it only intersects at once. Our second example, that looks kind of like a parabola is laid down, is an example of a non-function, because if I draw a vertical line on that graph, I intersect the graph at two separate points, making it a non-function. Alright, so like I said before, we're pretty much going to work with functions in this class. Non-functions we'll get to later in the year, but for the most part everything we'll work with is a function. And you need to be able to look at the representation of a function in four different ways. We call them the four faces of a function. You can represent a function as an equation, such as y equals 2x minus 5. We could then, if we wanted to, create an input-output table or an xy table for that equation, plugging in an x value, getting a y value, and we could find a set of points that are representative of that equation. We could then take those points and put them on a graph, connect them, and look visually at what the function looks like. And finally, we can do a verbal description of a function where we have something like y equals 2x minus 5. We could say to get y, you would take x times 2 and subtract 5. Now, this is a question that I might see coming on a quiz or test. Hint, hint, you might want to know this. Now, because this chapter is going to require some formula work and things like that, I am going to allow you to use notes on any test or quiz. So I could very much see a question like, what are the four faces of a function, being something you'll see later. So you might want to pause the video here and write these down. So our other piece we're going to go over today is going to be slope. And now I know you spent a lot of time with slope in Algebra 1, so we're just going to cover it quickly. The definition of slope is simple. It is the steepness of a line. And when we look at that formula-wise, you've been taught a lot of different things. And in here, I'm going to try to use all three definitions of slope, as one person may be more comfortable with one, another person might be more comfortable with another. I want you to make sure you can calculate slope, whatever makes you comfortable. So here are our three definitions of slope, and slope will always be represented by the letter M. I understand that doesn't work in the English language. However, it comes from the Greek word for slope is where the M comes from. So you were probably originally taught that slope is rise over run. When you're looking at a graph, you say, how much do I go up? How much do I go over to go from one point on a graph to another? And that's kind of your visual way of looking at slope. Rise over run, where rise refers to up and down, running refers to how far over you go. Then my personal favorite for slope is to look at change in y over change in x. In other words, to look at your 2 points that you're working with and saying, how much is your y value changing? How much is your x value changing? And writing that as a fraction. And now you notice as you start to look at this, slope is kind of backwards from what we're comfortable with. Every point is written x comma y, so we often have trouble with flipping our slope upside down. Make sure you are careful on that. And again, you might need to make a little note in your note sheet or wherever saying that slope is y over x. It is kind of upside down to what is common sense. And so if you look at rise over run, change in y over change in x, it's the exact same thing, just another way to look at it, because y controls up and down. Rise is the amount you go up or you go down. Change in x refers to left and right, because x controls left and right. Run refers to left and right. And finally, the formula. The formula to calculate slope is to take your point and take the y value of your point and subtract them. Take the x value of your points and subtract them. And then write that as a fraction. If you have trouble with slope in any way, I strongly suggest using the formula. The formula is a little more work, but it always gets you to the correct answer. And to end today, we're going to look at a couple of special slopes. The first one is a horizontal line. If you have a line that is horizontal, it will have no slope. Therefore, the slope is 0. It has no steepness whatsoever. Vertical lines, we define the slope as being undefined because it is unmeasurable. And when you think about working with 2 points, as you see in parentheses, if 2 points have the same y value, that makes it a horizontal line, so the slope is going to be 0. But if 2 points have the same x value, that means the bottom of our fraction is going to be 0, and that's one of those fun little math laws that never, ever, ever works. You cannot divide by 0, so therefore we have an undefined value. Last 2 things you need to know about slope. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of one another. So what that means is, whatever the slope of your original line is, a line perpendicular to that will have a slope that is flipped upside down and have the opposite sign. Alright, we'll do an example or 2 in class tomorrow, and good luck. We'll see you tomorrow.